There we go.
Problem 5.
Problem 5, okay. Oh yeah, thanks. You're patient letting me do my thing. Like, he needs to see it. I'll let him do that. Is it good? We'll let these guys get up close first. Okay. Problem 5 on the practice test?
Yeah, I did it in the homework, but the practice test one.
Oh yeah. Well, these two. All right. I will have to admit to you, I just took some old practice tests from the last time I taught 281, slapped them together, and when I started making the answer key for this, I was like, man, you guys aren't gonna like what I'm about to say. I was a little easy on this. Yeah.
13.2
Say again.
13.2.
Yes. So the test goes from 12.1 up to 13.2. So all that homework is due Monday.
And the quiz correction.
Yes, if you want to turn the quiz corrections in, they're due by Monday also, unless you have already turned them in. You can turn them in today. If there's something you want to turn in today, consider just holding on to it until, because it's not going to make a difference if you give it to me now or Monday. You might as well keep it to look at, right? Because like you found out, sometimes I don't give it back to you when you want me to. Yeah, you're still, I love it. I can still see the steam coming out of your ears. All right. I'm going to call campus security to escort me to my house. Good jumps. So number 5 is the one about find the points or point where these things intersect. We've got to be to the point now where you can tell me what that would look like if you graphed it in, of course, R3. What would that look like? Plane. Now tell me a little bit more about it. So it's parallel to the... There you go. That's a nice, quick way to say it. I know what you're trying to say, but that's the quick way to say it. Two planes that are parallel basically mean their normal vectors would be... If I have two planes that are parallel, their normal vectors must be parallel. I love it. So that's a quick way to check if two planes are parallel. Just see if their normal vectors are parallel. And for vectors to be parallel, they have to be how related to each other? It's a very quick check to see if two vectors are parallel. If one is a multiple of the other one. I love it. Let me stop there for a second. Okay. So this would be a plane that is parallel to the xy plane, xz plane. How far away from the xz plane is it? Square root of 2 away. I love it. All right, cool. And then the other guy is this beautiful monster here. And of course, they give you a range there. So it's almost, this kind of problem, bless you, it's almost too nice to believe. I mean, how do I find the intersection of two lines? How do I find the intersection of two lines? I give you a line equation, another line equation, and I want to know their intersection. And I'm talking like 2D. X plus y equals 7, x minus y equals 4. If I graph them, I look for where they intersect. Algebraically, I can use the elimination method, or more generally useful is the substitution method. I know this one has y as rad 2. What's y for this guy? Yeah. There it is. Yeah, set them equal to each other. When do these guys meet? Well, this only has, its x and z components are everything. So the defining idea of this plane is that y must be rad 2. So this is going to meet that plane when its y is rad 2. I like it. So this is the approach you should take is assume the problem is easier. If that easy approach doesn't work, then maybe it's harder. Because a lot of you guys go right for the hard stuff. And I'm like, holy shit, that might work. I don't know. Yes?
That's a plane right there?
No, this is a one-dimensional, some kind of curly cube, right? I don't know if I said it was plane. So when is this vector function, which is some kind of curly monster, when does it hit this plane? Yeah, when cosecant t. Now you see why I picked rad 2. Now again, if I give you like 3 pi over 4, or as an input, or rad 3 over 2, or rad 2 as an output, I don't want to see no decimal freaking answers, or right? These are things you should know. So if you want to, cosecant t equals square root 2 means sine t equals 1 over rad 2, so rad 2 over 2. Now that should be a little more obvious, right? When is that true? For t equal to what? 5 over 4 or? Now there. Sorry, do it again. I love it. When it's sign positive, it's either going to be in the first quadrant or the second quadrant. 5 over 4 reference angle, second quadrant is, I think I heard it, yeah, 3 pi over 4. All right, let me stop there for a second. This is a curlicue dude. If it hits it once, it might come around and hit it again. It might hit it an infinite number of times. And it sort of does, but it probably repeats itself, right? More than likely. It could repeat itself, although with the cosecant in there, it might be open-ended. But I gave us a limited range, thankfully. Thank you, Jeff. So then what can I do with this? What is this? What can I do with this? Yeah, plug it in. Plug it in. Yeah. So then R of 5 over 4. Cool. I like it. I like it. I like it. And what's the... All right. So what do you get for pi over 4 there? What do you get? What's cosine of pi over 4? So you get 3 rad 2 over 2. This is rad 2. I knew that from the beginning. Don't redo this and get some other answer. I know it's rad 2. And then this is 2. Yay. And then for 3 pi over 4, the only thing that's going to be different is... Yeah. So just do that to capture both of them. Those are what? I just wrote 2 things down there. What are they? Physically, what are they? I mean, are they planes? Are they spaces? Vectors. Totally a vector, right? Vector components, right? This is a vector. I like it. So what's the connection between the vector and the points that I'm asking for? I asked for points. Yeah, just write it without that stupid thing. Because this is a vector that's pointing to the point that's in that connection, that is that intersection. So you just write it without the absolute value symbols, right? Write it like this. Bam, bam. Now it's points. Yay! All right, maybe. That was actually the very first question at all in any homework here. Very first question in 12.1. The connection, yeah. The weird thing, and I don't know if you guys have picked up on this, is when we define a curve or we define a plane, our vector points to points that are on that curve or in that plane. It's a little weird, but at least it maintains that connection between vector, point notation. They're almost the same. Yeah.
So when talking about the derivative of a vector equation, would it be the slope of the vector tangent somehow to the curve?
It's not always tangent unless there's a certain condition there, but
Yeah.
I mean, it's not always perpendicular, right?
Yeah.
So it has to be a certain kind of curve to be perfectly perpendicular, yeah. But, I mean, they have better pictures in the book, but if I had something where this was R, then R prime would be still the same idea. Where would this thing go if it was suddenly released from whatever's making it stay on that? We're having a good time on the roller coaster, and then, oh shit, how would we fly off the coaster if gravity suddenly went away or something, whatever, right? Let us fly forward. I like the whole idea of this and then, Same idea. Same idea. So it's going to point in the direction that that point would fly. It's kind of nifty. Certain curves, this will be perfectly perpendicular. Yes, sir.
I'm sorry, totally unrelated, but you might know this. Is that what makes, like, is that what makes the gyroscopic effect happen?
There's a little bit more,
Okay.
a little bit more involved. All right, cool. I like it. So we can go anywhere you guys want to go. You're all like, I want to go get some ice cream. I think that'll get us ready for the test. Whatever you guys want to talk about.
38 on 12.5.
So this one's asking for an equation of this plane. So what's the most useful version of the equation of a plane? Probably the most immediately useful.
The scalar average.
And what's that look like?
Normal vector.
X minus x naught plus b times
0. And what they do next is they kind of multiply this through and they collect it all and they call that all that mess D. But you see why this to me is the most useful? Because what can I see in it? What is A, B, C? What's that vector? The gas. And what's x naught, y naught, z naught?
starting point.
Point in the plane. I like it. Yeah, become a 0. And we like to say in instead of, excuse me for getting semantic, but if you say on, it's almost like it exists a level above the plane. So this is in the plane because it's at the same level of the plane. Does that make sense? It's not like a table with something sitting on it, and I'm getting way too detailed, but just to make sure. Okay, cool. Just in case you have something that really is stuck up about it. So what do we know about this? So I know what I need to figure out. And sometimes they'll give me the information where I have to use a different version of this, but this is the one that's probably the most useful for most problems. They give me, it has 2 points it passes through. Well, that's cool. I need at least one, so I got 2 points. Where'd you go? And it's perpendicular to the plane. Ooh, I like it. You would, Jeff. Perpendicular to... Let me write it in the way they meant to write it. Okay. So this should feel a lot like an old algebra problem where they said, give me the equation of the line that goes to the point 1, 3, and is perpendicular to the line y plus 3z equals 7. Easy. I have to get my 2 things I need. I got the slope from the fact that it was perpendicular to the other line, right? I can get the slope that way, and they just gave me a freaking point. So, how can I use this to get something I need?
Well, I mean, it has to be parallel to the normal vector.
Yeah, in order for 2 planes to be perpendicular to each other, what must be true about their normal vectors? They have to be perpendicular. Does that make sense? If I want my planes to be parallel, then so let me see if I can do this. Sort of. No script. If I want, so remember the plane is at the end of the marker. Is that cool? Can you imagine a plane sitting at the end of my marker? So if I want the 2 planes to be parallel, then their normal vectors must be parallel. Now as I turn this, can you imagine that sheet just turning? Yeah. If I want them to be perpendicular, then the normal vectors have to be perpendicular. That's kind of nice. That normal vector is my immediate go-to thing that I can work with that defines my plane. Before we knew about normal vector, if I said, how do you tell if 2 planes are perpendicular, you would have been reaching, you'd be like, I don't know, what the freak? But now we know that this defines the plane. So what's this guy's normal vector?
5, 5 minus 2.
So my normal vector, so let's call this one and perp. So my normal vector has to be perpendicular to that. All right, that's one piece of information I've got. Yes?
So, could you say to find out the normal vector of A, B, and C? Since you said its dot product equals 0.
Yeah, if the dot product equals 0, then
If the dot
cross
product
product
equals 0,
equals
then
the
well, if the dot product is 0, then the two vectors are
perpendicular.
beautiful. Yeah, exactly. I love it. Now, that's still going to give me a system, or one equation with 3 unknowns in it, right? So what I don't know currently is I don't know my normal vector, but like you just said, I know that my normal vector dotted with that normal vector has to be 0 because they have to be perpendicular to each other. Yes, sir.
You pull a point off that plane.
Sweet.
That's yeah. So you can set C equal to.
We got a whole other set of information we haven't used yet, but what's good is to work with something you realize, work with it as far as you can, and then step back and say, what have I not used yet? So if you're dealing with this, the next level, of course, what does this become? 5a
Plus 4b
plus 4b.
minus 2c equals.
Of course, Yes, ma'am.
Can you take those 2 points and create a vector and then find the vector orthogonal
Say,
to that?
take the two what now?
Take the 2 points.
Points.
in I. Yes.
Yes, I love it.
And then make a vector out of those 2 points.
Yes, the vector connecting those 2 points
Correct.
must be
Parallel.
Yeah.
yes. Cool.
And then take cross that.
Yeah.
I don't know what I said. But just like find the orthogonal vector to that vector.
So what would you get here? What would this vector? Let's call this vector. I call it anything else? No, we can call it B. Why not? What would that vector be?
-1, 5.
Sure, depends on which way you go, but yeah, -1,
5,
5,
-4.
-4. So that's a vector that I know lies in the plane, or is parallel to the plane. It could be put in the plane.
So the normal vector of that would be orthogonal to that vector.
It's not enough though. How many vectors are orthogonal to that vector? No. How many? If I have a vector sitting here, all of these are perpendicular. Oh shit! Right? Do you guys get that? This is why I love just going off what you guys say, because you got good ideas, but you got to start to realize, okay, that makes sense. I can't have one vector and get an orthogonal vector because there's an infinite number. You guys with me? How many vectors do I need, of course, to get a true normal vector from a plane? I need 2 vectors, and they only gave me 2 points to build one vector off of, right? Okay. So let's see what we got. We know that my normal vector has to satisfy this. True. And what's the equation of my answer is right here, right? So couldn't I plug in points? I could, right? And get another equation involving A, B, and C.
Plug it into that first.
So I'm just throwing some ideas out at you guys. What do you guys? Yes?
So you eventually have to construct a system, a linear system for each point, and then that way you get a solution.
So that's when you first look at this problem, that seems like it's probably going to go somewhere, right? Because you do get this. If you plug those points in, you get some other things. Yes.
Did you get direction for the new plane by crossing V with N?
You mean N? So you can get direction for your plane
Yeah, because it'd be orthogonal to both of them, and then you could use P or Q as the initial point for your new plane.
Yeah, so you got initial points here. I like it. Now, if you take V cross N
Yeah.
perp, where's that gonna lie? Take V. No, this is where it gets interesting. So V lies in the plane. How is it related? How is that already related to the normal vector of this plane? So a vector that lies in my plane, and my plane is perpendicular to this plane, right? I love it. I want to make sure everybody's with me. That's where things get weird. So the planes are perpendicular. That means the normal vector of one is going to be parallel, or at least not intersecting, right? Okay, okay. Skew, thank you.
Parallel, right? Because if it's in the plane, you could have a vector point that way and that way, and a normal vector as a plane.
But so like if you have the normal vector here, this could be any of these. This would be truly parallel. This would be what's called skew.
Oh, okay.
Where they don't intersect, but they don't maintain the distance between them, right? That's what skew is. I like it. So if I do this, what will I end up with? So I've got a normal vector that is parallel to, or at least skew with, that vector. What would that end up being if I did this? Well, yeah, it's going to be perpendicular to both. Sure. So it's going to be perpendicular to
The normal vector of the new sun as well.
this one, right? I like it. Okay.
Will it be the normal vector, like, or
So any vector, you gotta be careful. So if I have a single vector sitting there, again, there's an infinite number of other vectors that are orthogonal to it, right? Okay, cool. So if I cross it with something that is parallel to it, am I actually narrowing down? So have you tried to do this yet? 'Cause that's not the first way I thought of doing it, but that might work. Have you tried doing that one yet? V cross N?
Yeah.
What'd you get?
I got 6, negative 22, and negative 29.
Alright, cool. And of course, if you dot it with, now this has got to be perpendicular to both of these. My normal vector is supposed to be how related to this normal vector. We said earlier it's got to be perpendicular. I like it. So by doing this cross product, well, I like this. So this is going to be perpendicular to the normal vector like it's supposed to be, and it's going to be perpendicular to my plane, which makes it a normal vector for my plane. Sweet. I like it. So if I cross two vectors, I get a vector that's perpendicular to both. I know that my normal vector that I want for my plane has to be perpendicular to the other guy's, the given plane's normal vector. I know that's true. That's number one. Right here. This must be perpendicular to that. Also, my normal vector has to be perpendicular to any vector in the plane. So like this accomplishes both of those things. That's kick ass. So what is this then? What do I attach to this? What's the variables for this? Or what's the
ABC.
ABC? Because that's my normal vector. And of course, what's driving us, what's motivating us, the direction we want to go in is to always get these two things. I need a normal vector to my plane. I need a point in my plane. And you can tell from what they give you. If they give you 2 points, it's almost guaranteed they want you to use that vector that connects those. Almost. Right? But what's most important behind all this is just understanding what it means for two planes to be perpendicular. Right? Two planes to be perpendicular, normals have to be perpendicular. So how would I go from here? I've got my ABC. Do I have a point? Yeah, I can pick either one of those. And if you had time, you could use both of them and make sure that you actually end up with the same D when you consolidate all the stuff that's in here. Where'd it go? All this stuff here. It shouldn't matter which point you. It's just like in algebra when it didn't matter which point you used when you had more than one point for your line. Okay, maybe. I like that. So together we got through that. I like that. Anybody do this problem a different way? Did anybody do this problem, number one? A lot of you guys going, I got about halfway. Okay. Well, that's the way it works. I like that. Alright, so any questions on what we did in that problem? And again, I think I already said this. I said this to you. If you haven't abandoned the idea that somewhere there should be a list of, if you see this kind of question, you do this. If you see this kind of question, you should do this. That is long gone, right? You attack a problem with the ideas. So when they say find the equation of a plane, this is how I teach my algebra students about lines. When they say find the equation of a line, I focus on finding my slope and finding a point. When they say find the equation of a plane, I focus on finding a normal vector and finding a point. Cool, cool, cool. All right. What's next up? Any other questions? Yes?
When you integrate a vector, do you just do it by integrating its separate components?
Yes, totally. I love it. Now, to me, a really good question would be, what does that mean at the end, right? And the weird part about answering that question is, so let's do an example problem. Make sure everybody understands what's happening. That's the reason I didn't worry too much, as long as you remember your integrals. And that was the whole reason that first day I did that whole warm-ups and reminded you, you got to freaking go back and remember how to integrate, use substitution, all that kind of stuff at least. So if I gave you a vector, let's just do something real quick here. Yeah, I like it. Sure. And they ask you integral, what's the integral of this vector? Let me just say it like that. Let me stop right there. Very cool with the question I've written. Do you guys see the most important part of that integration? I mean, I know I'm going to integrate the function that they gave me. I know that's the integral symbol. Ooh, this is the most important part, really. I'm integrating with respect to t. Visually, where is that? When I integrate with respect to x, I can see x. There it is. So we know it's the area underneath that along the x-axis. Let me stop there for a second. When you start doing parametric, you have a t-axis that is not visually represented. You kind of with me? So there are some physical. If this is a velocity and I integrate it, I will end up with my displacement. Yes.
Yeah, because t represents time.
It could. Yeah. If this is a velocity and t is time, then that when I integrate it, I do get something physical. But I can't. You can't represent what this means on a picture very easily because the t-axis. Who knows where the hell that thing is? But now it's just as easy as. Now we're back in Calc 1, really, for this problem. So how do you integrate? So you can do it on down here if you want to. You can do each part alone. What do you use to do that? Or something guys hopefully...
U sub?
Yeah, you can use U sub. Anybody to the point you can just do that? Or if you need U sub, cool. I mean, what's the derivative of e to the t squared? 2t e to the t squared. Do I have a 2? No, so it must be over 2. I mean, that's, could kill the 2 that would be there. I know the answer. I know the integral of this has to be related to this. So then I adjust it so that the derivative comes out correctly. Do you have to do it that way? No. You're all like, that's the Jeff way. I don't want to do it the Jeff. So you can just do u is t squared. du is 2d t to dt. And what I hate is when teachers, you might have been taught to solve for dt. If you were, I am sorry for you. You probably made some really dumb mistakes doing it that way. I much prefer teaching people, make this happen, and then replace it with du. What do I mean? Do I have 2t dt yet? No, so I need 1/2 and a 2, right? Now I'm not going to make silly mistakes by solving for dt. I'm not going to think I can integrate when really I can't. And now you finally get 1/2 integral e to the u. So you get 1/2 e to the t squared. All right, let me stop there for a second. Is that cool? So now you're starting to notice that integrals of vector functions are evil because they're like 3 sets of integral problems, right? Now, please understand, I'm not just going to give you busy work and give you like insane components and go, now do it. By parts, this one, and this is a trig sub. Yeah, let's do it. I mean, those things might pop up, but I'm not going to load one problem down with all that. Right? The basic idea of how to integrate this is easy. So what do you get? 1/2 e to t squared. What's the integral of sine 2t?
Negative 1/2.
Beautiful. You have to 1/2 it to kill the 2 that wants to come out. So it'll be negative 1/2 cosine 2t. And of course that's just going to be
1/5.
who do what?
I'm sorry.
Oh, no, come on.
1/2.
There.
No, 2.
2.
2t squared.
2t squared. And then they're going to ask you to integrate from, and then you just plug it in. Now, what have I left off here? But I always